Now solve these questions. In the first few questions, you have to just write the elimination product, that is even products. You have to mention which one is major and which one is minor. In next set of questions, you have to write substitution product as well as elimination product. And in even products, you have to mention which one is major and which one is minor. I'll discuss once you're done with these questions. Let's discuss the solution of these questions now. So this will form the carbocation like this. There will be a shift over here. Okay, hydrogen shift, hydride shift, 1 comma 2 hydride shift, and this will become this. Okay, now we have now this MEOH will attack on the beta hydrogens. What all are the beta carbons over here? This is one of the beta carbons and this is one of the beta carbons. Okay, so either hydrogen can be removed from here, this carbon, or hydrogen can be removed from this carbon. This beta carbon is more alkylated and hence will give you the product as, this will give you the product as, there are two products which will be formed. One is this and another is this one, out of which this will be major and this will be minor. So I think I have taken the space for the second question, so I'll just rewrite the whole answer. This is the major one, this is the minor one, this is the answer for the first one. I'll just rub it off and I'll rewrite. So products are as I had already mentioned in the question that we need only elimination products. This is major and this is minor. This is Saytzeff product and this is Hoffman product. Okay. Similar way, I'll just explain you the working of this question over here because otherwise it will take a lot of space. So I have this which will form cyclobutyl carbocation. Now the cyclobutyl carbocation, if you remember, we had done in CPM that if the cyclic ring, if the cyclobutane chain, cyclobutane chain has a positive charge on the ring itself, it will try to become a CPM, and CPM has much better stability than your cyclobutane carbocation. So what will happen? This carbon carrying the positive charge will try to form, let's mark the number of carbons. This is 1, this is 2, this is 3 and this is 4. So carbon 1 and carbon 3 will try to form a bond and 3 will break its bond with 4 and this positive charge will shift on carbon number 4. So the chain will look like this. That's how the chain will look like. Now what all beta hydrogens I have? I have this beta carbon and I have this beta carbon. No, not this beta, I'm sorry. So I have only one beta carbon. This is the beta carbon. So what will happen? The removal of hydrogen will take place from this position. Hydrogen will get removed from this position by your base MEOH. It will pull out this hydrogen and will form this as a compound. So the product of this is, so there is only one single product here and this is the product. Okay. Now let's see the next one. What is next? In next case, oh, I forgot to mention the halogen over here. So this is, let's say this is chlorine. So now if chlorine is removed, positive charge will come over here. This is the beta carbon, this is the beta carbon. Now because both are symmetric, it really doesn't matter from where the hydrogen will be removed and hence the product formed will be this. Okay, this is elimination product. So this is going to be major here because there is only one product. This is also major here. There is only one product of elimination. Now in the next case, this is how the carbocation will be formed and then there will be shift of carbocation with a 1, 2 hydride shift. So rearrangement of carbocation will happen. and that's how the structure will look like. Now what all beta carbons we have? I have this as a beta carbon and I have this as a beta carbon. Okay, so removal can take place from here and can take place from here. So this is beta 1, beta 2. Beta 2 is more alkylated than beta 1. So beta 2 is more alkylated than beta 1. Okay, alkylated, and hence there are two products which are possible. One will be this and another will be this. Here the removal of hydrogen has taken place from beta 1, which is less alkylated. Here the hydrogen removal has taken place from beta 2, which is more alkylated. This is going to be the major product and this is going to be minor. This is your Saytzeff product and this is your Hofmann product. Fine. Now let's come to the next sequence of questions where we have to find out the SN1 and even both type of products. So again, let's see, this will be the carbocation formed. Now this carbocation will rearrange itself first even before the base or a nucleophile will attack on it. So this will rearrange in such a way that it will try to form a bond with this carbon and will break this bond. This plus charge will shift. So ring expansion will take place. We have already discussed ring expansion in detail many times before. So that's why I'm just doing it very quickly. So now I'll have plus charge over here. Now this plus charge, now I have two options over here. One is doing SN1 and another is even. Both will take place. If SN1 will happen, in that case the product form would be OMe over here. And if the even will take place, because now this position and this position, both the positions we have beta carbons and both the beta carbons are symmetric, so it won't matter from where we are removing the hydrogen, and we will get only one single product, and that will be this. Fine. So this is your even product and this is your SN1 product. This will be okay, there is no major minor over here. That will totally depend upon the temperature what we have provided. Now come to this. This is how my carbocation will look like. Now again, this carbocation will rearrange. No, not required, because everywhere the degree is gonna remain same. So two possible options, SN1 and even. If SN1 will take place, it will form the product like this, OMe. If even will take place, now we have two situations over here. One is the beta carbon 1 over here and this is beta 2 over here. Beta 1 is more alkylated than beta 2, and hence removal of hydrogen from beta 1 will give you the Saytzeff product. So the product will be plus removal of hydrogen from beta 2 will give you Hofmann product. This is Saytzeff product and this is Hofmann product. This will be major. This will be plus minus as this is a chiral center, and here we will have cis and trans. Okay, this will be minor. Now the last one. In this, how the structure will, what will be the carbocation form? The carbocation will be this. This will be the carbocation. Do we need any rearrangement in this? No, we do not need, because anyways we have got a tertiary carbocation. So again, two possibilities. One is SN1 and one is even. If SN1 will take place, OMe will directly come over here. Okay, and if even will take place, now we have to look on the beta carbon. So what all beta carbons I have? One is this as a beta carbon. This is beta 1. This is beta 2. And this is beta 3. So beta 1 is equal to beta 2. So these are basically same or symmetric. Not symmetric, you can say them, these are same. And if I talk about beta 3 seems to be more alkylated than beta 1 or beta 2. So I can choose either of the beta carbons to remove hydrogen. I can choose either beta 1 or beta 2, and beta 3 is the another option. So let's say if I remove hydrogen from beta 3, then the product form would be this will be the product form, and this is the Saytzeff product, and this is major. Okay, if I remove the hydrogen from beta 1 or beta 2, the product formed would be, this will be my product formed. I hope you have understood all the, and this is my Hoffman product. I hope you have understood the solution of all the questions. This is how you will be getting a question for elimination, and you will have to find out the major products. In most of the cases in exam, they will be just bothered about the major product formed rather than all the products formed. As we have already discussed, even will always follow a Saytzeff rule to get the major product. Okay, SN1 products are also will also be forming. Now, depending upon the situation, depending upon the temperature given, we will decide whether the SN1 product is more for that particular reaction or even product is more. If even product is more, then the Saytzeff product will be in the major quantities.